Hello student, today we are going to start our new reaction which is known as Nazarov cyclization reaction. So this reaction is introduced in 1941 by Nazarov scientist, right? Okay, in Nazarov reaction, now I am going to tell you the principle of the reaction. So in Nazarov reaction, your starting material is divinyl ketone. Divinyl ketone, which is converted to alpha beta unsaturated carbonyl compound. Right, so your starting material is divinyl ketone. Now what is the vinyl group? So as you know that this group, suppose here is the chlorine, so we can say that this is known as vinyl. So vinyl chloride, 2 carbon and double bond, and here any chlorine, or we can say that any R group. So this is the vinyl. Now one more functionality is also important. Suppose one carbon introduced here and here double bond, so this functionality was the vinyl. If one CH2 is there, then it is known as allyl group, right? This is the allyl group. So divinyl, so here 2 vinyl group is there, ketone is also there, which is converted to alpha beta unsaturated carbonyl compound, and the reagent for this reaction is LCl3 and concentrated H2SO4, right? So this reaction is performed using LCl3 and concentrated sulfuric acid. Okay, this is the principle. Now we are moving towards the reaction of Nazarov cyclization reaction. Now as we discussed that there is a divinyl ketone as the starting material. So let me take one simple example. This is ketone, one vinyl group here, second vinyl group here. Suppose here is the R, here is the R dash, right? So it may be aliphatic, it may be aromatic, anything. Okay, now your reagent is aluminum chloride, means LCl3 and concentrated H2SO4, and the final product is cyclized product. Alpha beta carbonyl compound is okay, but it is in the form of cyclic. So this is ketone, this carbon is alpha, this one is the beta. So alpha beta unsaturated carbonyl compound, remaining R and R dash is as it is. Clear? So this is the Nazarov cyclization reaction. Now as we know that here aluminum chloride act as a Lewis acid. Aluminum chloride act as a Lewis acid, and Lewis acid always accept the electron pair. Lewis acid always accept the electron pair. In the opposite side, if we are dealing with the Lewis base, then it always donate the electron pair. So this is the Lewis acid base concept. Clear? So Lewis acid, aluminum chloride, SbCl3, SbCl5, right? So these are act as a Lewis acid. Clear? So in Nazarov cyclization reaction, divinyl ketone is converted to alpha beta unsaturated carbonyl compound using aluminum chloride and concentrated sulfuric acid. So you have to remember that there is a 2 vinyl group with keto functionality, and your product is always cyclized product. Clear? So in Nazarov, जब भी नज़ारोव की बात आएगी आपको ये नाम से याद होना चाहिए, Nazarov cyclization reaction. That means your product is cyclized product. Clear? Okay, now we are moving towards the mechanism part of Nazarov cyclization reaction. So now we know that if we are adding concentrated sulfuric acid to any reaction, if we are adding concentrated sulfuric acid to any reaction, it always donate the H plus, right? It always donate the H plus. So your starting material is divinyl ketone. Suppose here is the R dash. So this is divinyl ketone. Okay. Now we are adding the H2SO4. H2SO4 means we are adding the H plus. H plus act as a electrophile. So electrophile always attack on the electron rich site, or we can say that the nucleophilic center. So here oxygen carry 2 lone pairs. So this lone pair of oxygen attack on the H plus, right? So as we discussed in our previous lecture is that always more electronegative to less electronegative side arrow notation is required, right? More electronegative to less electronegative. So we can say that here oxygen is more electronegative, hydrogen is less electronegative. So first of all, hydrogen attach with the keto group of our starting material. So here R and R dash as it is. So here O and H. Now here oxygen valence is 3. So here oxygen occupy the positively charged. Now as we know that the positive charge on oxygen is not very stable, that's why it attract the bonding electron pair towards itself. So in first case here OH double bond as it is, right? And this positive charge of oxygen is transferred to here carbon. Clear? Right? So again this positive charge transferred to, this double bond is transferred to this. Clear? So now this material is converted to here OH as it is, this double bond as it is, and now this double bond transferred to here. So now positive charge on this carbon. Why we are going to transfer this positive charge? So we can say that here conjugation is maintained, right? So here lone pair, single bond, double bond, single bond, carbocation, here again double bond, single bond, double bond. So we can say that here conjugation is maintained. So we are going to transfer the positive charge to where it is more stable. So as we know that tertiary carbocation is more stable than the secondary than the primary. Suppose let me take 2 examples. So we can say this is tertiary carbocation. So this one is the most stable because here 3 donating group is there, right? And here 2 donating group is there. So we can say that tertiary carbocation is more stable due to 3 donating site attached with the carbocation carbon. Here 2 donating sites. So we can say that tertiary is more stable than the secondary. So here positive charge is transferred to another carbon due to found the extra stability. Or we can say that if we put positive charge here, then it more possibility to cyclization. Clear? So now this bond attack on this carbocation. So now the cyclized product is formed. So here OH as it is, and here cyclization is formed. This double bond is also as it is. Now you are going to break this bond. So the negative charge, here positive. So negative positive combine and to form the bond, right? So now this positive charge is transferred to this carbon. Clear? This positive charge is transferred to this carbon. Clear? Now as we know that this carbon has 1, 2 and 3 valences. So your 4th valence is hydrogen. So here hydrogen released as a H plus. So मैंने कई बार आपको बताया है कि रिएक्शन में जो चीज़ पहले ऐड हो रही है वो लास्ट में निकलेगी, जो चीज़ पहले निकल रही है वो लास्ट में ऐड होगी. सो in the starting of the mechanism we are adding the H plus from the concentrated sulfuric acid. Now it's time to remove that H plus. So now this bond is transferred to here and H plus is removed from the system. So here OH, right, here R as it is, R dash as it is, one double bond here, and this double bond is generated by removal of H plus. यहाँ से H plus निकल रहा है, that means this carbon is negatively charged, positive negative combine होके it form the new bond, right? Now as per the reaction or as per the principle, your product is alpha beta unsaturated carbonyl compound, but here two double bond is there, so we can say that this functionality is the enol form, in plus all, enol, right, enol form. Now as we know that ketone form is more stable as compared to enol form, so let me transfer this form to its ketone form. How we are going to transfer? So this bond transfer to here and this hydrogen transfer to this carbon. Simply this bond transfer to here. So here carbon oxygen double bond is generated and this H plus is transferred to this carbon. So here double bond O, this positive charge as it is, here here hydrogen is there which is transferred from oxygen, one R is here and R dash is also here. So we can say that alpha beta unsaturated carbonyl compound is formed. So this is the complete mechanism of Nazarov cyclization reaction, right? So let me discuss one point at this time. In general case, many reference book use one word. They are sometimes using possible reaction mechanism. Possible reaction mechanism. Why this word is used? Because this is totally depend on the theoretical approach, right? Totally depend on the theoretical approach. Suppose you are going to start with some another catalyst, some another reaction condition, then the mechanism might be different, but the product is always same, starting material is always same. So you can write mechanism in any way, you can write mechanism in any way, but it should be theoretically possible, right? If you are going to add H plus and if H plus is attack on this carbon, R dash carbon, then it is not possible. So mechanism should be in best experimental condition and best theoretical concern should be fulfilled. Clear? Okay, now we are going to move the application part in the sense of example. Let me take the first example of Nazarov cyclization reaction. You can use any type of the mechanism or any type of the examples, right? But your functionality like match to the divinyl ketone. You can write anything here, you can write anything here, but the main important thing is divinyl ketone, right? Okay, in the presence of H plus, in the presence of aluminum chloride. So first H plus attack on here. Okay, let me discuss the mechanism also because it's the first example of this reaction. So here OH positively charged, here is the methyl group. Now what we are going to do, so this oxygen, so I am just telling you two step together. So this bond transfer to here and this bond transfer to oxygen. So as we discussed there, oxygen is the positively charged which is not very stable. So now it is converted to this double bond as it is converted to OH. So here carbon is positive charge which is transferred to this carbon because this bond is transferred to here. So here transfer, here is the positive charge CH3 as it is. So in next step cyclization, this bond transfer to here, right? So here OH, and we found the cyclized product, this bond as it is, here methyl is as it is, and now the positive charge is here. So in last step removal of H plus, because in starting we added the H plus, so now it's time to remove this H plus. right? This arrow notation, I think you know how I write this arrow notation. In simple, suppose if you are not able to do like this, so just break the bond, just break the bond. So here positive charge, so you must put negative charge here and positive charge here. So H plus remove, this positive and negative combine to form the bond, right? If we are not able to draw this arrow notation, then you can break the simply bond. यहाँ पे पॉजिटिव है, you must put negative here, because पॉजिटिव पॉजिटिव पास में नहीं रहेगा, नेगेटिव नेगेटिव पास में नहीं रहेगा. पॉजिटिव नेगेटिव कैन अट्रैक्ट ईच अदर, पॉजिटिव पॉजिटिव रिपल इट इज अदर. So your product is now right H plus here, so double bond generation here OH, here is this CH3 and this is enol form. So now enol form is converted to keto form, right? So it is now converted to here keto, this bond transfer to here, this bond transfer here, this oxygen transfer to here, right? CH3. So we can say that alpha beta unsaturated carbonyl compound is the product. Clear? So in the application part, you can it's not required to go for the mechanism, but if you are unable to give directly the product, then you must go for the mechanism, right? Any type of the mechanism, you must remember the concept only, right? We are going to discuss the reaction mechanism general case, so you are that much able to apply this concept to the any of the reaction. So let me discuss the second application of the Nazarov cyclization reaction. In this application, I am going to give directly the product. Yeah, one new concept is there. So in first case, एडिशन ऑफ H प्लस का यहाँ पे अटैक होगा, राइट? अब ए बॉन्ड यहाँ पे नहीं ट्रांसफर करवाना, ए वाला करवाना है. ए बॉन्ड यहाँ से ट्रांसफर नहीं करवाना है. क्यों नहीं करवाना बाद में दिखा दो. ए वाला यहाँ पे क्यों करना वो दिखा, बिकॉज हियर इज द नाइट्रोजन ग्रुप, राइट? सो नाइट्रोजन की वजह से ये जो पार्ट है वो इलेक्ट्रॉन रीच होगा एज कंपेयर टू दिस वन. सीधी सी बात है, हमें इलेक्ट्रॉन को डोनेट करना है. सो आउट ऑफ द टू डबल बॉन्ड, if one double bond is electron reach side, then we are going to move from that bond. Right? The first reason is that here nitrogen group is there, which is okay contain the lone pair. That's why it give easily this double bond to carbon. So H plus attack here, this bond transfer to here, right? So I am going to write the directly third step. So here OH, right? Here is the SiMe3, right? So first case, it attack of H plus, this bond transfer to here and this bond transfer to here, and here is the positive charge, right? Here is the positively charge. So one double bond is also here. So now this bond transfer to here. Right? So here cyclization and here SiMe3. Now this bond transfer to here, that's why positive charge on this carbon. Clear? Okay. So in previous reaction we are going to remove the H plus, but remember that this is trimethylsilyl, TMS. So this is already we discussed in the Mukayama reaction. This is trimethylsilyl, which is act as a protecting group, but when it is in the form of TMSCl, but here only TMS is there, so we can say that trimethylsilyl act as a living group. It is act as a living group. So instead to leave this group, instead to leave the H plus in regular Nazarov cyclization reaction, here this living group is removed from, so from trimethylsilyl cation, right? So it is removed as a Me3Si plus, right? So here bond is formed. So this is the something different from the regular Nazarov cyclization reaction, right? So here SiMe3 act as a leaving group, so you must generate the positive charge here. That's why I am going to start with this double bond. If I am going to start this double bond, then here hydrogen is removed as H plus, but from starting it's a leaving group, so मुझे यहाँ पे कुछ भी करके पॉजिटिव चार्ज लाना था. यहाँ पे पॉजिटिव चार्ज लाने के लिए I have to start from this double bond. Clear? So this is the enol form, and now it is converted to keto form. So this is alpha beta unsaturated carbonyl compound, right? So that's it with the Nazarov cyclization reaction. Divinyl ketone is converted to alpha beta unsaturated carbonyl compound, but in the form of cyclized product. Remember that in Nazarov cyclization reaction there is a cyclization. So on the basis of name you have to remember that there is a cyclized product is formed. Clear? Happy learning.